For this demo on filtering for low points, and for many of the others that are going to use more computationally intensive point cloud tasks, I'm just going to use a single tile in the LP360 tutorial data. I've chosen one that has a little bit of water area in it, as well as some buildings and representative land cover. Here I've zoomed into the extent of the single tile. I've also added a Bing aerial map as a backdrop from a WMS. I'm going to check my project path to make sure I'm going to the defaulting to my working folder, and also check the project spatial reference system. If you want to follow along at home, I suggest making a copy of this single LAS file and putting it in the working folder for this demo, because you will be making edits to it. I'm using tile 1744661 southeast. The tutorial data has already been classified. And for the purposes of this demo, we want to act as if we're working with data that is essentially raw. So we're going to have to reset the classifications back to some sort of an initial state before we continue. We can do that using a simple point cloud task. I've defined one already called Demo 520 Initialize. And in this point cloud task, I'm simply going to take all the points that are already classified. I'm going to leave the water points and the class 11 points alone. This is following the recommendations in the tutorial instructions, but all of the additional classes, ground and vegetation, buildings, of course low points and so on, I'm going to select those as my source and set them back to class 1 unclassified. I've applied to save, and now I'm going to execute on the LAS file. Recall that I have to change it to read-write in order to make any changes, and I'm going to execute by envelope. That went pretty quickly, and now you can see that indeed all the points other than those few water points down in the lower right-hand corner have been set back to class 1. Now I'm ready to go ahead and build a point cloud task that will find low and isolated points. Before I go on, I just want to mention that many of these point cloud tasks now, the specific parameters become somewhat subjective. There are some suggestions and there are defaults. LP360 will look at the data, and based on point density and some other characteristics, it will suggest some defaults. So the values that I'm using in this demo are not real right and wrong answers. I'm just selecting some values so that I can demonstrate the use of the tools. And then as you go through the exercises on your own, you can make changes to those and adjust those to see what the effects will be. I've created another point cloud task called Demo 520 Low Points Single Point. And the purpose of this will be to find individual points that are significantly lower than the surrounding points. Since we've reclassified our data, our source now are going to be all the points on class 1. Our destination class will be class 7, low point noise. And we're looking for individual points, so we're going to use a cluster size of 1. LP360 suggested a default search radius of 20 feet. I'm going to increase the default z-tolerance of 5 feet to 10 feet just to make sure that we capture only those points that are significantly lower than the surrounding. I'll press apply, and again execute by envelope. Note that I'm using execute by envelope because there is presently a bug for some of the point cloud tasks if you attempt to use the execute by project button. Now that I've run the task, I would like to view the results. there aren't too many low points, so it's difficult to see them zoomed to the full tile at a reduced resolution. So I'm going to create a filter that looks only, a custom filter that looks only at low noise. I did this using the stored filter manager. I'm only displaying class 7. I'm also going to make the points a bit larger using live view. I'll set them to a point size of, let's say, 8. And I'm going to force 100% resolution. Okay, now we see it found only 10 low noise points. Let's examine those points a little further using the profile tool. I'm going to open the profile window and make it a bit larger. And now I'm going to draw a profile over an area that contains a couple low points. I'm going to change the settings in the profile window to also display by class, and I'm also going to make the points a little bit larger so we can see them. Alright, and now you should be able to clearly see these 2 purple points that are significantly lower than the surroundings. And indeed, if we left those points in our unclassified data set, when we go to make a minimum grid, these are going to be identified as the lowest point in that area and cause there to be a pit in our minimum grid surface. Let's use the profile tool to examine a few of the other low points. Find a similar situation here. And again, some of these are not terribly low, but definitely lower than the surrounding surface. We aren't going to worry too much about the cause of these few isolated low points because there's so much other data in these areas that eliminating a single point from the potential bearer surface is in no way going to degrade our final answer. For the purpose of this demo, and so we can do a little bit of comparison, I made a second copy of the same LAS file and loaded in as a new layer. In the low points single point cloud task, we were looking for a single point that was significantly different in elevation within the search radius. If there were more than one point that had an anomalously low elevation, those would not be tagged. So now we're going to run a second point cloud task called low points grouped points. And in this case, we're going to look for clusters of points that have anomalously low elevations. This time I'm going to use the default search radius of 20 feet and z-tolerance of 5 feet that were calculated by LP360. Now again, I'll change my display filter to low noise so I can isolate the results. I'll set my point size again to 8. I'm going to make group 7 a different color this time so we can compare the single point and the grouped point results. So I'm going to go ahead and change that purple to red. And I'll force 100% of the points to the screen. I found 47 points this time, so this is including the 10 from before and an additional 37 that were identified as grouped points. If I drag the single points layer and put it on top of the grouped points layer, you can see the purple are the original single points and then the red are the new grouped points that were found. Let's look at some of these new points in the profile window. And there you can see that we do have some that are grouped together now as low points. Let's take a look over here in this water area. And notice that those low points don't really jump out as being terribly low compared to the rest of the surface, but again, taking those few points out of the minimum grid is not going to really affect our final results. This can sometimes happen in water areas where the LiDAR returns are somewhat sparse. This is an example of the kind of judgment call one often has to make when running these point cloud tasks. You'll never get a 100% perfect solution, but you just need to make a decision whether errors of omission or errors of commission are going to ultimately be more detrimental.